So this is problem 76 from chapter 4, Giancoli 6th edition. So what we have is a box, and this box is on a surface, on a table, and this box is connected through a cord to a bucket that is hanging here. Okay, and well, we have the mass of this box. This is given to us. We also have the mass of this bucket. This is given to us. And we want to know how much sand we can put inside this box, so called MS, the mass of sand, so that this system will just start moving. Okay, the mass of the box is much bigger than the mass of the bucket, so if I do not put any sand, this system will be at rest. But if I put enough sand so that the bucket becomes heavier than the box, the motion can start. So we want to know how much sand we can put. Okay, so before putting the well, let's start putting the forces, and let's also choose a reference frame. So I'm going to choose that to the right is positive and down is positive. All right, let's put all the forces in these objects. Well, we have the weight of this bucket, so it's the weight of the mass of the bucket. I'm going to put also sand, so I'm going to put here also this MS, mass of the sand, G. Okay, we also have the tension through this cord, so this is the tension force. The value, the magnitude of this tension force is the same here, that is pushing the box. In addition to that, we have friction. The box is touching this surface, and there is friction parallel to the surface. So I'm going to put the friction force here. And we also have the other forces on the box. We have the weight of the box, and box G. And since it's touching this surface, we have this force of contact, the normal force, which is always perpendicular to the surface. Okay, so we drew all the forces. Now let's go for the equations. So I'm going to start here writing the equations for the box. And the equation for the box, we see we have to write the equation in the x direction and in the y. So I'm going to start with everything in the x direction. So we have the force, the tension force, minus the friction force. This first part of the problem, called part A, is the one that is asking how much sand we can put so that we do not start the motion. We are about to start the motion. Okay, so if we are not moving yet, we are dealing with static friction. Okay, so there will be no motion. That means the acceleration is 0. So that's the point of where the motion will start. Okay, from this equation I could try to get the tension force, but I'm stuck here because of the friction force. How do we find the friction force? Well, we know that this is equal to the constant, right? The constant of static friction, because we are not moving, multiplied by the normal force. And what is the normal force? I can get the normal force by going to the equation in the y direction. The equation in the y direction is the weight, positive, of the box minus Fn, according to my frame, equal to 0. That's all. Okay, so from here we get what Fn is. Fn is just the weight of this box. So we can put it here. This is the mu and m box G. All right, so I do find from this expression the force, the tension force, right? So I'm going to keep this here, and I'm going to go to the other part of the problem, because the question of the problem is not the tension force. I was just able to find it. I'm going to go to the other part of the problem, which is the bucket. And so let's focus now on the bucket. What are the forces involved in the bucket? Just the weight, and the weight here is positive, so it's the mass of the bucket, which we know, plus the mass of the sand, that's what we are trying to find, multiplied by G, minus the tension force, and this is equal to 0 because we are not moving. Okay, now I have the tension force that we obtained up there when we are using the equations for the box. So I can use this tension force here to now find the mass of the sand. So I'm going to put mass of the bucket plus mass of the sand, G. And now instead of the tension force, I'm going to put what we found here. So it's minus the coefficient of static friction, mass of the box, G, equals to 0. So everything here we know, we have, and we can find our unknown, the mass of the sand. Okay, now let's suppose we put 1 grain more. 1 grain more, so the mass is about the same, it doesn't change. It's a tiny difference, but this will start the motion. Okay, so this will start the motion, and now the question of the problem is part B. What we want to know is what is this acceleration. Okay, so nothing changes in this problem, the forces are still the same, but now we do have acceleration. So if we go for the box, the equation for the box, everything is very similar. What is going to change is that instead of 0, we'll have ma. So let's just write these equations. For the x direction, we have force of tension, the tension force, minus the friction. We already know what is the friction, so I'm going to write it here. Mu, careful now, because now you have to put the one from kinetic friction, because we are moving, so this is the dangerous part, easy to make mistakes. Then we have the mass of the box, G. So this whole thing here is the friction force, but kinetic. And this is equal to, now we do have acceleration, so we have to put m box A. And this A is positive because we are going to the right and we chose right to be positive. Now, if we go for the bucket, what I'm going to do for the bucket is I'm going to call big M the mass of the bucket plus the mass of the sand, because we already found the mass of the sand, so I have now a number here. All right, so what is the equation for the bucket? Well, the same that we had before, that mass of this whole system, bucket plus sand, G, minus the tension force, and this is equal to M of this whole system, bucket plus sand, A, and A is what we are trying to find. Okay, so now we have these two equations, the equation for the box, the equation for the bucket with sand, and we want to combine them to get the acceleration. So what we are going to do is I'm going to isolate the tension force from here. So the tension force is big M G minus MA. And now I'm going to put this whole equation, this whole FT, up into the equation for the box. Okay, so if we do that, let's see what we get. We have mg minus m big M A. We have the mu of kinetic friction. We have mass of the box, G, equals to mass of the box and our unknown A. So now we can find the A with this equation.